So the first component to be soldered to the printed circuit board is the solid state relay. You can see that the solid state relay is purchased with the pins facing down. To minimize the use of space on the printed circuit board, we have to change the orientation of the pins so they're pointing up. So all we do is, with a pair of pliers, fine needle nose pliers, is straighten the pins and then continue to bend them until they point upwards. Then what I do is, with a pair of small wire cutters, is cut off the end of the pins so when we add it to the circuit board, the pins don't protrude through. So after the pins of the relay have been bent and cut to length, you can lay it on its back and you can now see a dot that correlates to pin number 1. This pin needs to go into the top right hand corner of the position that we have for the relay on the circuit board. So all we do is take our relay, turn it over so that the dot is facing down in the top right hand corner. If we push and hold the relay in place, we can see that the pins are level at the bottom of the printed circuit board, and it's now ready to be soldered. So now that we have our solid state relay soldered to the printed circuit board, it's now time to add the Arduino Pro Mini. We attach it to the circuit board through a series of pins. Now again, I like to cut the pins short, and so they've only got a length of about 1 millimeter, so that they don't protrude through the holes on the circuit board that we've prepared. Now again, to save space on the circuit board, we've designed it so that the Arduino actually is mounted below. So we take our pins and we put it on one side, and we put the pins on the other side. And those are the pins in place. We'll now go ahead and solder them, and then we can add the Arduino. So now that we've soldered the pins onto the bottom of the printed circuit board, you can see the advantage of cutting the pins before we solder, and the low profile that it produces, and the advantage that will be given and allowing us to place the XP on top here. You can see I've also cut the pins on the bottom to a short length, and this will allow us to place the Arduino in position and not have any pins extruding through. You can see here I've got the 3.3 volt Arduino Pro Mini from SparkFun. We take it in this orientation, turn it upside down, and then place it onto the pins. Again, this orientation allows us to minimize the use on the printed circuit board by minimizing the number of traces, and it also leaves the communication pins available to us at the end of the data logger. So now that we've soldered the Arduino to the circuit board, we're now in a position to add the breakout for the micro SD. The first thing that we do is we take our pins, which again we've cut short, and we solder it to the bottom of the printed circuit board into these holes here. So what we will have is our printed circuit board with our pins facing down. We'll go ahead and solder those in place. So I've finished soldering the pins for the breakout for the micro SD card, and you can see with the black strip of plastic still in place just here. Now if we attach the breakout to these pins, you can actually see there's quite a substantial space left. Now, considering that this data logger is for use on wildlife, we want to keep everything as small as possible. So to get the lowest profile, what we're going to do is we're actually going to remove this black strip from the pins. Now I do it with a scalpel blade, and I just push it down between the pins and the printed circuit board, and I slightly pull the black plastic away, and then I just keep on pulling with the scalpel or I use a pair of needle nose pliers to pull it off. So I'll go ahead and finish that now. So I've finished soldering the pins for the micro SD breakout. I've removed the black strip of plastic and I've cut the pins to length. And this will allow me to solder the breakout onto the bottom of the printed circuit board, and it gives us a really low profile, which is good for attachment to wildlife. The problem, however, with this is it obstructs access to the pins for the GPS, which makes it difficult to solder them in place. So before we attach the micro SD breakout, I suggest that you go ahead and solder in the pins for the GPS. And these pins go on top of the printed circuit board and face up. So I'll go ahead and solder those in place now. So I've soldered the micro SD breakout board to the bottom of the printed circuit board, and I'm ready to attach the GPS antenna to the top of the printed circuit board. One of the things that I do first of all is that you can see the pins from the SD card are still visible, and the bottom of the GPS antenna is metal, so obviously we'll get some shorting out if we put it directly on top. So what I'm going to do first of all is I'm just going to get some insulation tape and I'm going to put it on the bottom of the antenna module to insulate it from the SD cards. And once I've done that, I'll then go ahead and solder it to the top. I also suggest that you let the insulation tape come out of the side a bit so that the pins from the solid state relay are also protected from the bottom of the GPS antenna. So this essentially completes the GPS data logger, and if you're able to recapture your wildlife, you can simply remove the SD card and download your position data. But if you want wireless capability, you're going to have to add an XB module. I have two XB modules here. There's the 1 milliwatt and the 60 milliwatt. The 60 milliwatt has a larger range. I can pick data up from 1100 meters. That's over a kilometer, just under a mile. This smaller unit only has a range of about 100 meters. So depending on how close you can get to your wildlife to download the signal will define which unit you want to use. But just be aware, if you use the 1 milliwatt version, you can get up to 10 days worth of data, collecting information once every hour. But using the 60 milliwatt version, it's more demanding on the battery and it will only last about 2 to 3 days. So once you've decided which XB module you're going to use, you can then go and solder it onto the top of the printed circuit board in these pins here and here. And for this wireless data logger, I'm going to use the 1 milliwatt version. And so this is now the completed wireless GPS data logger with the XB soldered on top of the printed circuit board. You can see that because I've used the 1 milliwatt version, there's a great deal of space left between the XB and the solid state relay. If you were to use the 60 milliwatt XB, you could see that that space would actually be taken up by the XB. So if you only ever intend to use the 1 milliwatt XB, you can download the file for the printed circuit board and you can push the pins for the XB backwards and save some space. Or alternatively, what you can do is you can actually cut off this fiberglass printed circuit board here. I haven't been able to find any circuitry that runs through this piece of fiberglass, and I've cut it off in the past and everything has been fine. But I warn you to be cautious if you do so. The only other thing I'm going to do is, because we use the wired antenna, we need this wire to point upwards so that there's no interference with the circuit board below. So I recommend not to use the printed circuit board antenna, but to use the wire antenna. Is that this can often be quite fragile. So I'm actually going to take some epoxy and I'm going to strengthen the antenna at the base here and also underneath the XB there. Now, the final thing to talk about is the battery. I use a 400 milliamp hour LiPo battery from SparkFun, and the reason I'm using that is because it's also got a low profile and the final unit is very small indeed. So the only thing we have to do now is attach the wires and include a switch if you wish. I'm not going to spend too much time talking about attaching the wires and use of switches because every use will be different. What I have done in the past is I've included a small connector beneath the XB. This requires me to raise the XB on a series of extending pins, which you can also purchase, and then all I do is insert the plug into the socket and it is powered. You can do that, or you can insert a small micro switch, or you can solder it on in the last minute if you've got that facilities in the field, or you can have two bare wires that you can just wind together. So I'm just going to talk briefly about where you supply your power to the Arduino Pro Mini. This is a unit that I haven't put onto a data logger yet, but you can also see we have a unit that we put onto a data logger. And just remember that we turned it upside down, so the orientation of the pins are all reversed. So if we go back to this Pro Mini, you can see there are a number of ground pins. There's 1, 2 and 3. And you can provide your power source to any of those ground pins. That would be your negative from the battery. If you're using the 1 milliwatt XB transmitter, I suggest that you supply all your power through this raw pin here. Now this is where you supply your unregulated power source, and the onboard voltage regulator will convert that to 3.3 volts, and every system on the data logger will be happy, including the XB. If you're using the 60 milliwatt, the onboard voltage regulator won't provide enough amperage to power that and push the signal out to the full range. So you're either going to have to provide a direct power source to the XB, which means it won't last as long, or what I have been doing is connecting the positive power from the battery to this VCC. Now be careful, because what's happening here is you're pushing unregulated power through the Arduino. I haven't had any problems yet, but it could be if you push too much unregulated power, you could fry the board. So I would recommend pushing all your power through this ground pin and this raw pin so that the voltage regulator, wherever it is on this board, can take care of the voltage.